We are back again with the question 2. This has two different topics. One is with the quadrilaterals and the second one is about trigonometric functions. Now let's begin with the quadrilaterals. Quadrilateral is anything that is having four sides. It's an enclosed figure with four sides. Quad means four. This ABCD is a quadrilateral. It's a rhombus. They have also mentioned it's a rhombus. And we need to find whatever they have asked, okay? And some angles are already given. Now, if it's a rhombus, then all the sides are equal. And this over here, the diagonals, right? The diagonal is from one end to the opposite end. When you draw a straight line, that is a diagonal, will make 90 degree when they cross each other. So all these are 90 degrees and all the opposite sides are equal to each other. That's congruent. Now here they have told ABD. Now remember, they will always give you ABD or CBC, something like that. Sorry, CBD or something like that, to specify an angle. You might be wondering, why don't they just give you B is equal to 60 degree? Because whatever is in the middle, that is the angle over here, right? Why don't they give us just B? The reason is B can be this one or this one or this one. There are three possibilities, right? So therefore, we need to realize over here, A, where is A? It starts over here, then B is over here, and D means it goes down. So this is the angle only. It's not other sides or not the total angle. Let's look over here. B, D, C. From B to D and from D to C, it will be this angle only. So this is why it's very important. These are the two alphabets. Now we know this is 60 degrees. Now what is the opposite side? Now this is alternate opposite angle. See, this is the same side, right? Now this is an angle and this is an angle. One more thing you need to remember here, a rhombus, right? When you see one of the diagonal, it will cut into two equilateral triangles. So this is equal, this is equal, this is equal, right? Now these will be alternate interior angles basically. They are opposite, right? They'll be equal to each other. So that is the thing. Rhombus is a special case. Even these are also equal. This is also 60 here. This is 60. Also, this will be 60. So otherwise, it's alternate interior angle. And now, what about AE? AE is given to be 8. We need to find what? AC, the total length. Now, this diagonals bisect the other diagonals. This is one more important thing. If this is 8, that means the other side is also equal, because the bisection, this segment bisection means it will be bisected equally into two parts. If this is 4, this is also 4. That's how it is. So the first answer was 60, and over here we have, okay, now we forgot to find out AC. This is 8, add them up, it will be 16. So 2 times 8 is 16. And now over here, you might be thinking, what do we write, isn't it? Most probably these are very simple problems. In just 2 sentences, you can get the answer. They'll be maybe a part of a question. You might get A question as this, and B another, and C another, something like that. So if you just know how to solve them directly, it's fine, you know. So now let's look into the next problem. It's again the same figure. It's a rhombus again. And we have AB here. That is 26. And what about BD? BD is this line, sorry. That is about 20. So we need to find AE, this one. Now we can see this is a triangle, right? And we know this is 90 degrees. So this is right angle. So what is that side? It will be the hypotenuse over here. And what else? Now we want to find AE, so I'll put X over there. But what about BE? We know the total length is 20, so half of that will be BE. Always it'll be cut into half, bisected, right? So we know 28, 10, and X. So we can use Pythagoras theorem. As long as this is 90 degree, we can easily use it. So here from Pythagoras theorem, the hypotenuse, that is AB square, will be equal to AE squared plus BE squared. Now let's substitute the values. It's 26 squared, that is equal to AE squared is X squared plus 10 squared. Now let's use a calculator. This is a big number. So here you can directly solve this in the calculator. I'll show you how. It's 26 squared equals, that is alpha and calc, that's equal to, and X is by alpha and this symbol over here, and square it up, plus 10 squared. Here we go. Now don't press equal to, it'll be an error, syntax error. You need to shift, solve, and then press equal to. That will be the final answer. That's the correct answer, 24. So that's how we get it. Or if you want to do the steps, you can just do 26 squared. That is 676 over here. 676 equals x squared plus 100, and take this to the other side. It'll be 576 is equal to x squared, and take the square root, it'll be 24 equals x. So these are the steps if you want, or this is just substitution. So you can even jump over here. You must get full marks, because as long as you know the formula, the substitution, and then because you're using calculator, you can directly jump to over here. So that would be the answer. And now let's look into the measure of CEB. Where is CEB? It's a 90 degree, right? All these diagonals bisect each other and cut it to 90 degrees. Now CBD, that is over here, CBD is 58 degrees. What is ACB? Where is ACB? This one is not known. ACB. So this is 90 degrees. So all we do is, if we add these three angles, let's take this as x. Let me add it up. 90 plus 58 plus x would be 180 degree, because it's a triangle. Now you can easily solve it up. Take it to the other side. X will be equal to 180 degrees minus 90 minus 58. So 60 would be 30. 32 would be the answer. X is 32. And over here we have AE. Let's see, this is given as 3x minus 1. And AC over here, the total length is given as 16. What is x? Now you can do it in two different ways. I know that AE is half of AC, because AC is the total length, right? AE will be equal to half of AC. So what is AE? We can just substitute 3x minus 1 is equal to half of AC is 16. Now you just solve it up. 3x minus 1 will be 8, because half of 16 is 8. This goes to the other side. 3s is equal to 9, because minus 1 to the other side will be plus 1. 8 plus 1 is 9. And x is both divided by 3 will give you 3. X is 3. Another way is, see, this is the total length 16, right? So half of it will be 8. You can directly substitute 3x minus 1 is equal to 8 and solve it. Or you can write over here a is equal to 8 and then start solving it from here. The answer will be the same anyways. So the answer is 32 over here, and we got x as 3 value. And over here we have few more problems. Measure of this M angle means measure of the angle CDB is 6y degrees. CDB, this angle is 6y. Measure of ACB, whereas ACB is 2y plus 10. And we need to find the value of phi. So now how would we do this? Now from here, 6y, how can we get any information over there, right? But there is one important thing which you must remember. This angle is being bisected and these both are equal, isn't it? So this is also 2y plus 10. So this angle is 2y, this is the 6y, and this is 90 degrees. Now we just add them all up. So 6y plus, see now, though ACB is this angle, ACB and ACD are equal to each other, congruent. So therefore, we can just add them all up. Plus 90 degree will be equal to 180. Now you can just put this entirely in the calculator and solve as well. But I'll just solve over here in detail. 6 plus 2y is 8y. 90 plus 10 is 100. So I'll just take 180 minus 100 to the other side. And over here we have 80 and 8y. Y will be divided by 8 both the sides. It's 10. Now what about this? AD is over here. I'll just change the color. AD is 2x plus 4. And what about CD? This one over here. CD is 4x minus 4. What is the value of x? Now here, this diagonals, right? Break these into equilateral triangle, isosceles triangle. I'm so sorry, isosceles. The base angles are equal, and these two sides are also equal. Now even these, they're congruent, they are similar triangles, by the way. So now over here, if these two sides are equal, then these two are also equal. So you can directly equate them both. So how we do it is, just 2x plus 4 will be equal to 4x minus 4, and just solve it up. This to the other side will be plus 4, okay? Plus 4 again. We have 1 4 already, and this minus 4 to the other side will be plus 4. Because 4x is bigger, that doesn't change its side. Only the 2x, which is smaller, moves to the other side. And we have 8 is equal to 4x minus 2x will be 2x. 4 is equal to x. This is 4. Okay? That's the answer. Now here we got 10, and over here we got 4. What next? Over here they have given us a square. Now it's not a rhombus. Now you might be thinking, what is rhombi or rhombus? Rhombi is the plural form. Many rhombus are rhombi. If there is more than one rhombus, singular is rhombus. More than one is rhombi. So that's just plural form. Now PQRS is a square. If PR, that is over here this side, this is given as 42. What is TR? What is TR? This one. Now that's just half of it, right? It's pretty simple. Just divide this by 2, that will be it. PR is equal to half of TR. Sorry, TR is equal to, this is half of the total one. Or PR is equal to 2 times TR. That's it. So it'll be 21. That's the answer. And now here we have another, again the same value, and they have given us km. Okay, km is this. Okay, is 26.5. What is kh? Now this is just times 2. So it'll be 52 plus 1 is 53. That is it. Just multiply this by 2, you'll get the total, and this is all pretty straightforward. Now, oh sorry, 26, 25. Yeah, I think so. It's 53 here. This is wrong. I'll just show you in calculator as well. All you do is 26.5 multiplied by 2. The answer is 53. Here there is an error. I'm sorry for that. This is supposed to be 53 here. Now we move on to the problems with two-column proof. Especially this one is a little bit tricky. We have to prove a lot of things in this. Now, when we start solving this, whenever it's two-column proof or any problem, whenever they ask you to prove it, let's always do a two-column proof, okay? So that is a very... Now we will move on to two-column proof problems. We have to prove them. These are proving problems. We have to make two columns. Let me just draw them straight over here and something like this. One will be over here statement, and then over here we will write the reason. Okay. Now, if they ask you just to prove, always try to make this two-column statement and reason, and then prove this, whatever they ask. There is always a trick. Whatever is given to you will be the first statement, and the reason is just given. Whatever is given, you write it blindly over here. A, C, D, H, and B, C, D, F, okay, are parallelograms. So what I'll do is I'll just draw parallelogram like this for short form, because many times you have to use that term. Okay, that is parallelogram. But you guys in your exam, just do it properly. Okay, write it properly. Parallelograms. And they have told BF, line segment BF is congruent to AB. This is another thing. What is the reason? It's just given to you. And always the last one will be ABFH, that is a rhombus. That will be the last statement. So if you can't write anything, at least write the first thing and the last thing. You will at least get a couple of marks over there. So now let's understand what is given. ACDH, that's the entire quadrilateral. And the right side, this one, this quadrilateral BCDF, they both are parallelograms. That means all these opposite sides are equal to each other and parallel to each other. And over here also, they both are equal and parallel, even these two. So now what next? BF, this line, right? BF is this line. So this one is equal to AB, okay? And we have to prove ABFH is rhombus. See, whenever they told this rhombus, I can easily remember one statement. If you have two consecutive sides of a parallelogram, equal to each other, two consecutive means this and this next to it, or this and this, or this and this down ones. If they're consecutive means continuous sides are equal to each other or congruent to each other, then it is a rhombus. But so now we need to prove this is a parallelogram, ABFH, right? We have to prove it to be a parallelogram. Let's do it now. What can we prove? We have to prove these two sides are equal to each other and these two, AB and HF. So I will just write over here, we need AH equal to BF, okay? Congruent like this, two lines and then upside, okay? That's congruency over here, that's the symbol. And we also have to have AB is congruent to HF. So these are the two things, these line segments. That is what we are looking for. Then it's a parallelogram, then we can easily prove it. It is a rhombus. Now we will start with the side. See, the entire thing, we know AH. See, I'm not going to write two steps. See, generally what they write is AH as a segment is congruent to, CD, and then we also write AH is equal to CD. What this means is this is a line segment, and this is, you can input the values or you can use the substitution. I'll just directly write it, please understand. I'm not going to write it two times. Whenever you write line segment, we use this symbol. It's congruent. You don't write equal. When it's not a line segment, we use equal to, okay? Now, it's just understood here. I'm sure even if you write like this, the teacher will give you full marks because it's understandable. Now, AH is equal to CD. And what else? This BF is equal to CD. Why? Because it's a parallelogram. Parallelogram properties. You can just you can write your own reasons. I'm writing my own properties. Okay, next. Here CD and CD both are there. So from transitive property we can write AH is equal to BF. Why? Transitive property. Transitive property. If there are C, A is equal to B and B is equal to C, so A and C must be equal, right? If this is phi, this is also phi, phi and phi. Transitive property. Okay. And what next? Let's also do this one, BC and FD, right? See over here, this AC and H, like we did this vertical sides. Now let's do the horizontal. It's not slanted, slant sides, horizontally slanted one. So over here we have AB, not AB, sorry, AB is not given. It's AC is equal to HD and BC is equal to FD. Now it's the same thing. This is over here, okay? And then we can write what? Okay, let's not write anything because we don't have any comparison to make as of now. But we have just written what is there. From the given, we are just making some statement. Now, all this, whatever you can see, just write over here. Write some lines. Because sometimes students get confused. If you write something like this, you will get at least plenty of marks, So now our goal is to get this one. This is already done over here. Very good. That is done. Okay. Now you can write over here below like this, but just leave it like that. It's fine. Now we know these two sides are done. But how can we prove AB and HF? So we need to write AB somewhere. How can we write AB? We know total AC, right? AC is equal to AB plus BC. Isn't it? Segment additions. So I'll write AC will be equal to AB plus BC, and what is this? Here HD will be equal to HF plus FD. Why? Because this is segment additions. Segment addition. And then what else? If I know AC and HD, see, now we know AC and HD are equal. So can I write AB plus BC is equal to HF plus FD? That's it. And why do I do this? It's by substitution. Substitution. Okay. So what next? Now this is done. We need only AB and HF. I need to cancel BC and FD. But I know over here BC and FD are equal, right? So what I can do is, again, substitution over here. AB plus BC, let us keep it like that. But HF plus, I'll write BC itself. I'm substituting this value. So this cancels off. From here I can tell AB is equal to HF, isn't it? So this is the second thing proven. So this is just by, solving over here. And now these two are done. So what can I tell? ABFH is a parallelogram. ABFH is a parallelogram. Parallelu. Okay, you can just write. Sorry for my spellings. It's already written in the question. You can copy it from the question itself. And then over here, why? Because opposite sides are equal to each other. Opposite sides are congruent, that is like this. Okay, now here you can just write this as line segment, that is also fine. Okay, you get the gist of it, right? This, when you write the line segment, they are congruent. If you're just writing this, you're right equal to. Now if this is the case, then we know there is a rule when two consecutive sides AB and BF are equal, right? When two consecutive sides, you should write TWO. Don't write any numbers. When you're writing in words, you just write with words everything. I'll just remove that. So here, two consecutive sides of a parallelogram makes rhombus. Parallelogram is a rhombus. Okay, is a rhombus. That is proven. Now what is it? The same thing. ABFH is a rhombus. That's it. Because these two are given. So the given will be such that you can easily prove it. Obviously, all the problems can be proven. They'll give you required information, and then whatever provable is possible. Now here, this is the information what we have to solve. We have to do AH equal to BF, that is done, and then we have to do AB and HF, that is also done. These are the only two things, main things, and then parallelogram and rhombus. I hope this is clear. Let me just see the. I think so. The solution set is too big. I mean, oh, yeah, it's the same thing. They have written a few extra things. You don't write all this. I mean, you don't need this in detail. As long as you write few words, whatever I've written is more than enough. You can just look at this. You can pause the video now and write it out if you want. Let's go to the next problem. It's another proving problem. Here they have told this is a parallelogram. QRST, it looks like a square, and they have given us TR, the line segment TR, and QS are congruent to each other. Okay, the diagonals are congruent, that's very important. And QPR, okay, this one, they have told also QPR is also what? 90 degrees, and we have to just prove it to be a square. So in order to prove this is a square, we need to first try and prove rhombus or rectangle, because it's a parallelogram. Okay, we'll just start now. Now here what we will do, statement, reason. This is very important. Now reason. Now here, first of all, they have given, right? You need to write the given, this things as it is, and write given. Okay, this one over here, that's the first thing you need to do. Next one, here, since the diagonals, what do they tell about the diagonals? Diagonals are congruent, right? If the diagonals are congruent, what it is? It should be a rectangle. It's either a rectangle, square, or rhombus. But we can't prove it's a square or rhombus, but it's definitely a rectangle because that's the rule. If, now I'll just write over here, QRST is rectangle. Rectangle, because you don't need to write because, okay, but I just wrote it anyways. You don't need to write this because the diagonals are congruent, if a diagonals of the parallelogram, now this is already told it's a parallelogram. Now diagonals, here you should write diagonals of parallelogram, okay, parallelogram are congruent to each other, congruent congruent. Okay. Now, if you want to write it in short, you can just write congruent as the symbol. Or congruent. That's enough. And then what next can we write? Now, next one over here, they have told us. See, they have told this QPR, right? This is 90 degree. So what does this mean? If this is 90 degree, all are 90 degree. That means they are perpendicular to each other. The diagonals are perpendicular. So now I'll write over here the diagonal QS is perpendicular. Now I'll write line segment is perpendicular to RT. Now the diagonals are perpendicular. It's basically perpendicular. They have told it's a right angle. Okay, you can write various things. I'll tell over here it's because they're perpendicular lines. Perpendicular lines. And then what else can we write? Now here, if the diagonals are all, this is inside over here, are perpendicular each other, that means they're 90 degrees, then this is a rhombus. QRST, that's the property of a rhombus, is a rhombus. Okay, because the diagonals are perpendicular. This is the symbol of perpendicular. Okay, diagonals of parallelogram, if they are perpendicular to each other, you should write this. So your diagonals of parallelogram are perpendicular, therefore it's a rhombus. So these are the properties, the theorems, the theorems which have gone through in the lesson. These are being used now. And now what next? Now if any object, if any parallelogram is a rectangle and a rhombus, then it's directly a square, because rhombus already proves that all sides are equal. Rectangle will prove that it's all 90 degrees. So that means it's a square. QRST is a square. Done. Is a square, because over here, if a quadrilateral is a rectangle and a rhombus, then it is you can just write no need of writing if, because if means you have to tell it is a square. If quadrilateral is a rectangle and rhombus here, therefore it is a square. That's it. This is a simpler one compared to the last one, but still you need to know the theorems, the rules of all these quadrilaterals. Then you can easily solve it up. So yeah, even over here it's simple. I think so they have written one or two extra, but still it's fine. But you don't need to write in detail, but as long as you convey the important information, that is more than enough. You can just copy this down. Yeah, this is very important. The first statement will always be whatever is given to you in the question and the reason is given. So we'll move to the next one, another proving problem here. Now WZ, XY, okay, this seems to be simple because they have told all these are parallel. And what did they give? WX is congruent to XY. Okay, these two lines, consecutive sign. Okay, whenever they tell you there are two consecutive sides are equal, then it mostly goes towards what? It's a rhombus. Okay, we can easily prove this rhombus. Now, all we need to know is this is a parallelogram. If this is a parallelogram, there are two consecutive sides equal. Directly, it's a rhombus. That's the property. Now, statement, reason. Okay, SR. Now here, what all we know? WZ, okay, this one. WZ is parallel to, that's all given, XY, comma, WX parallel to XY, sorry, ZY, and WX is congruent to XY. This is given. That's the first statement. The next one, look, the opposite sides are all parallel. They've already told WZ, this one is parallel to XY and WX is parallel to ZY. If the opposite sides are parallel to each other, then it's a parallelogram. So WXZY or YZ is parallelogram. Over here, opposite sides are parallel. Okay. That's the reason, parallel, that's it. This is not there. And then if this is a parallelogram, then we know these two consecutive sides, this one and this one over here, are equal. So WXYZ are is rhombus. It's a single one. So is rhombus. Why? Because consecutive, two consecutive, okay, it should be TWO, two consecutive sides of parallelogram. Okay, it's parallelogram. I'll just do the shape. Parallelogram are congruent or equal to each other. That's it. So this is two consecutive sides of parallelogram. See, parallelogram are congruent or equal to each other. So hence proven. That's it. So given only two statements we have to write, only one statement. That's it, and directly we have to prove it. Yeah, this is so easy. You can see over here. This is a theorem which we have studied before. That is what we are using over here. Now here there's another one. I think so. This is the last one. Yes, it's the last one, I believe. I hope so. Now JKQP is a square. Okay, this is a square already told. ML is bisecting JP and QKQ. Okay, we know JKLM. Okay, the above one is also part. We have to prove. Sorry, we know only this is a square, but we don't know whether the above figure is a square or no. Only the entire figure is a square. We have to prove this above thing is a parallelogram. Now, how would we do this? Again, same thing. Statement, reason. Let's write it out. Statements, reasons. First thing will be given. This entire thing over here. That's given. And then let us see what we can use. See, we need to just prove this to be parallelogram. Now, in this case, this is already, okay, if we know this will be parallel, this is already parallel to each other. Why? Because we know it's a square. Now, we have to just prove this to be congruent to each other. Why? Because here, yeah, this is a square, but the midline bisection, we don't have much information about the middle lines. So we can, they have told over here, ML is bisecting. So I can easily find these both and I can prove this. So I'll just focus on the ends or the sides, okay? Now what we will do over here is, first thing, JP is congruent to KQ. Why? Because opposite sides of square, opposite sides of square, you don't need to write opposite sides. Sides of square are congruent because they have told square, all sides are basically congruent, okay? Now what next? I know this is bisecting, see this ML line is bisecting JP and this KQ. So I can write JM is equal to MP and KL is equal to LQ. ML is bisector. Or you can write, definition of bisecting, segment bisection or something like that. ML is bisecting, right? That's fine. Now over here, what I can write is, what is JP exactly? JP is equal to JM plus MP. JM plus MP. And over here, KQ is KL plus LQ. Now this is by segment addition, segment postulate, segment additions. Okay, this much is done. What next? We can tell, now we can say, instead of JM and MP, okay, let's substitute this over here, JM and MP over here, okay? Sorry, what I'm trying to say is, JP is equal to KQ, right? Let's just substitute these two over here in the first thing. So it's JM plus MP. It's like the first problem which we proved, right? It's similar to it. Is equal to KL plus LQ. It's easy to get confused, at times even I get confused over here. It's just substitution over here, substitution. And then now, we know JM and MP are equal to each other. So MP is basically JM itself. We can write, instead of J M and MP 2 times JM. Why am I writing the above JM? Because we have to solve only parallelogram, that is JKLM. So above sides JM is important, and here KL is important. So I write 2 times KL. So 2 cancels off. JM is equal to KL. This is by solving over here, substitution, solving. Okay. So now this is done. Now we have to write one statement here. JM is parallel to KL. Why? Because opposite sides of a parallelogram or a square, it's square, they're parallel to each other. It's like parallelogram. Square is a parallelogram basically. um, Square means parallelogram, so it's understood. And now over here, if JP and KQ, I'm not writing all the details. If JP and KQ are parallel to each other, obviously JM and KL also must be parallel. So I've directly reasoned it and I've written it over here. Now JM and KL are equal and they are also parallel, so JM KL, JML. You can't write JMKL. You would write JKLM or JMLK. Over here they have asked JKLM, so I'll write JKLM is a parallelogram. Just the question over here. In the question they have told. Okay, parallelogram. Why? The property of a parallelogram. If a pair of opposite sides, it must be opposite. Okay, this or this, JK or ML or JM or KL, opposite sides are congruent. We did congruency, congruent and parallel. So that would be the answer. So this is also a bit lengthy. Now, anyways, it's done, proven. Let's look over here. Okay, they have used plenty of statements. I mean, see, you can do a lot of statements or you can even reduce it. I hope this is more than enough for you guys. If you have written this, I'm 100% sure almost all your teachers will give you full marks, because you have understood the concept, you have written whatever it is required, and then you have solved it. So that's it, So that's the thing. And we will now move on to the next one. So we are finally done with the proving, I believe. So let's look into these problems. BCDF is a square. Okay, this given one is a square. FD, where is FD? This is 55. Find each measure. What is BC? It's also 55. What is CD? CD is also 55. Okay, they're all 55 then. So this is congruent, equal to each other. What about GD? Okay, now this becomes interesting. GD over here. Now we know this one, BD will be BD will be 2 times GD, or if you find BD, we can easily find GD. We know all the sides are 55. This is 55. This is also 55. So how can we find this? By Pythagoras theorem, it's 90 degree, right? This is a square. All sides are 90 degree. So from Pythagoras theorem, what can I find? I can easily find that BD squared will be equal to BC squared plus CD squared. Now BD squared is unknown, so I'll take it as X. Okay. X squared is equal to 55 squared plus 55 squared, or I can find X is equal to square root of 55 squared plus 55 squared. This is basically 2 times. Anyways, we'll directly put in the calculator and solve. Here you need to just put the square root. 55 squared, you can times it by 2 because it's the same number. It is 77.76. But this is not the answer. You need to divide this. Now let me just write it over here. X is 55 root 2. But now when you divide this, it'll be 27.5, I believe. Divided by 2. That's it. 38. Now, what I was telling, 25, that's 55 divided by 2 will be answer. And you can write it in terms of root 2. But over here, let's write decimal. And they have told round it off to the nearest tenth. I will come to that in a minute. So here GD will be equal to half of BD. So GD is equal to half of, you don't need to write it, I'll directly write it over here because we already solved it. It's 38 point. Now, nearest tenth, 10 means there is 1 0 in 10, right? So after the decimal point, you must see how many zeros? One only digit. 8, 9 will become 9. This is the answer. It's 38.9. That's the correct answer over here. I hope this is clear. 38.9 is correct. So that's how we do it. First we find BD and then we solve it up. Okay, we need to find BD. We just now did it, right? So we're here, using the Pythagoras theorem. So that's it. Then half of that will be GD. What about ZX? Where is ZX? Oh, now it's a different square. WT is given. See, this one is given to be 3. Okay. WT. ZX is over here. This is the total length. Okay. This one we need to find. Let's do this first. So here now, this is a square. If this is 3, obviously this is 3, and the diagonals are congruent to each other. These both are equal. So ZX will be 6. Why? Because this one side, the one of the part is 3. So all the sides will be equal. It's 3 and 3. ZX would be the sum of XT and ZT. So that's it. Its answer is 6. Now what about XY? Where is X and Y? This is the thing. Now we use Pythagoras theorem over here because this parallelogram, the diagonals bisect at 90 degree. We know that's even for rhombus and for square. So to find XY, you just have to use Pythagoras theorem. So XY, its opposite hypotenuse, square will be equal to 3 squared plus 3 squared. So it will be XY is equal to square root of 3 squared plus 3 squared. It will be, root 2 and 3. It will be 3 root 2, but you can just put in the calculator and find what is the exact measure. Square root 3 squared plus 3 squared. That's it. And the answer will be ST 4.24. Now, since they have not told us to round it off, find each measure, you can just write 4.2 or you can write 4.24. They have not mentioned how much decimal points. Okay, they have just considered it to be 3 root 2. That's it. From Pythagoras theorem, that's very important. And here, a few more problems. Now we are finding the measure. Now, what is the measure of WTZ? WT and Z over here, this one. It's 90 degree. Done. WYX. Where is WYX? Now, this one over here. So, what we do is, okay, these diagonals, right, bisect this. So, this is 90 degree. Half of 90 degree is what we should find. WYX, isn't it? This is 90, so since this diagonal is bisecting, it will be half of 90, that is 45 degrees only. So the answer is 45. Over here it's 90, over here it's 45. And now we move on to the trigonometric topics, Now we have to use calculator to find the measure of B. So before we move on over here, I'll just write the formulas of trig functions. You can easily remember this by SOH, TOI. It's SOH, Ka is CAH, Toa is TOA. Now it's up to you. You can use other acronyms as well. Or you can just remember sine has to do with sine theta is has to do with opposite by hypotenuse. Whereas cosine theta is equal to adjacent by hypotenuse. And lastly tan theta is opposite by adjacent. So these are the three formulas, very important. Now here you need to see what you need to find. I need to find the measure of B, isn't it? The angle, measure of angle B. So now this one will become theta. That means unknown angle. Theta is one of the letter in the Greek alphabets. So now here we have theta B. B as theta. What are known? This is 90 degree. This is hypotenuse. We don't have that. Leave that. What is opposite to theta? This one over here. We have opposite. And what next? This is adjacent. So adjacent, sorry. Which is giving you adjacent and opposite? This as hypotenuse, we can't use this one only. So we use tan theta value, a tan theta formula. So we write tan theta is equal to opposite by adjacent, and then we will just substitute over here. So what is tan theta? You can write tan B or anything. Anyways, I'll just keep it as tan theta is equal to opposite is 14 divided by 8. Now use a calculator and to the nearest 10, that means we have to take tan to the other side. It will be theta is equal to tan inverse 14 divided by 8. Now you just put it in the calculator and you get the answer. To get tan inverse, you need to see, if you click on tan, it's just tan. Press shift and then tan, you get tan inverse. 14 divided by 8, close the bracket. The answer is 60.25, but you need to the nearest tenth. 10 means only one digit after the decimal point. So theta is equal to 60. Now phi is there, that means this value number changes. From 2 it will become 3. It is 60.3 degrees. So measure of angle B is equal to 60.3 degrees. That's the answer. So here 60.3 is the correct answer. Now we have another problem. So I'm just going to erase this over here. Let the formulas all be there. And let's see what is given to us. Here they have told to find measure of B itself. Again, it's same, theta. Now the opposite side is unknown. We know the hypotenuse, opposite to 90 degrees hypotenuse. This is known. And we know this is opposite but not given. Adjacent is given. Which formula now? So the formula over here will be whichever is having hypotenuse and adjacent. That is cosine. Cosine theta is equal to adjacent by hypotenuse. You need to write this formula first. Now we'll write cosine theta is equal to, substitute, adjacent is 25 divided by 30. So don't write cosine again. Let's just write theta is equal to cosine inverse of 25 divided by 30. Okay, so here it was, yeah, this is it. Just put it in the calculator and you'll get the answer. Here, to get cosine inverse, you have to press shift and cos. That will be cosine inverse. Sorry. 25 divided by 30. Just close the bracket here. And then the answer is 33.55. Nearest strength would be 33.6. So you can see its answer is 33.6. Now I'll quickly solve them up. Let me remove all the formulas. Now you need to remember it by yourself. Please do try to solve them all by yourselves, but I'll solve these anyways. So measure of B, this is the B angle, that is theta. Opposite side is unknown. The hypotenuse is known. And adjacent is known. So again, hypotenuse and adjacent is only given by cosine theta. That is adjacent by hypotenuse. So I'll substitute. Cosine theta is equal to 7 divided by 39. You have to just take the inverse. So it's theta is equal to cosine inverse of 7 by 39. You put it in the calculator and get the answer. Here it's already cosine. I'll just change this to 39 and over here to 7. And the answer would be, after rounding off to 10th, it will be 79.7. So you can see here 79.7. So this is important. Look into the question, how much you have to round off, and then, write the final answer. Let's do this one over here. They have asked to find the measure of T. So this is opposite. And after this, we have, this is hypotenuse, which is not given. And over here, we have adjacent. So now what we do is, we need to remember which formula gives you opposite and adjacent. If there is no hypotenuse, then it's only tan theta. So tan theta is equal to opposite by adjacent. And over here, opposite is 14 root 3 divided by 34. That is tan theta. Theta will be equal to tan inverse of 14 root 3 by 34. And that will be the answer. So shift and tan gives you tan inverse 14 square root 3 divided by 34. and close the bracket. 35.49, which will make it 35.5. And again over here, let's quickly do this. Measure of angle T, theta, opposite is known, and this is hypotenuse. Opposite and hypotenuse is given by sine theta, that is opposite by hypotenuse. Now theta will be equal to sine inverse, I'm directly writing it, of opposite by hypotenuse. Let me substitute the values. Theta is sine inverse of opposite is 7 divided by 18. That's it. You just put it in the calculator and round it off to the nearest tenth. That'll be sine inverse of 7 divided by 18. And let me close the bracket over here. 22.9 would be the final answer. Why? Because we had a round of 9. So you can write theta is equal to 22.9, and then measure of angle T is 22.9 degrees. Don't forget the symbol degrees. Here as well, let's do it. T is 30, opposite is unknown, hypotenuse is known, and this is adjacent, that is also known. So hypotenuse and adjacent is given by cosine theta. Whenever your hypotenuse, it's either sine or tan. If it's adjacent, it's it's sine or cosine. If there is no hypotenuse, then it has to be tan. Now here, cosine theta is adjacent by, here we have hypotenuse. So theta will be equal to cos inverse of adjacent is given as 34 by 87. Now another thing, if you have written these wrong, you will understand hypotenuse, no matter what, will be the biggest side. Okay, it has to be the biggest side. So here there is, okay, you understood this is opposite for theta. Now here you have these two sides. This has to be hypotenuse, which is opposite 90 degree or the biggest side. So now we'll just substitute over here cosine inverse of 34 divided by 87. And you need to close the bracket properly over here. And the answer is 66.99. Now nearest tenth. Now what happens over here is it'll be a number more. So this number more, 9, means this will change again over here. It'll be 67.0 degrees because I've clearly told it's the 10th. So it's 67.0 degrees. Why? Because it's 9. Now this 9 makes this to a bigger number, that will be 0. And over here you need to increase it by 1, 67 degrees. So that's the answer. And now over here they have told us to solve all the, round the sides. Okay, everything. We need to solve each right triangle. That means you need to solve all the angles and the sides. Now the angles are pretty simple. If this is 90, this is 32. And over here, that will be 50, 60, 58. This will be 58 degrees. And now what about the sides? Let's first write each and every side. This is known, but what is it? Now here, before we start, it's up to you to choose which angle you want to solve. I personally choose only one angle. Whatever is given, right? I'll just consider that to be theta. That's it. I'm just going to choose this theta and I'll just change the formulas according to it. So this is my opposite side. Opposite will be 11, and opposite to 90 degrees is the hypotenuse, that is not known, and the remaining one is adjacent. What I will do is I'll take this hypotenuse as x and adjacent as y. We can't solve hypotenuse and adjacent together because both are unknown. So from the formula, we will choose theta, whichever is having opposite and hypotenuse, and another one with opposite and adjacent. I'll write it out over here. First, I will write sine theta. That is equal to what? It will have opposite divided by hypotenuse. And what is the other thing which is having opposite? That is tan theta. That is having opposite by adjacent. Now, why I don't take cosine theta? Because I don't know hypotenuse and I don't know adjacent. Cosine theta is adjacent by hypotenuse. These both are unknown. So this is the thing. So I will just stick to one angle. My theta is only 32 degrees. I'm not going to change that. So the opposite sign is not going to change. It's going to be only this side, 11 itself, and hypotenuse will be x. and adjacent will be y. Now I can solve them up. Why? Because I know sine theta is 32 degrees. What is this opposite side? 11 divided by hypotenuse is unknown, that is x. And here I have tan 32 degrees, that is equal to opposite is 11 and adjacent is y. Now I can just substitute these entirely in the calculator and get the answer as well. And I'll show you the steps as well, both the ways I'll show you here. First thing is you can just write sine, not inverse, sine 32. Okay, equals is by alpha and calc and divided by 11 over here, 11 divided by x, that is alpha x. Shift and solve and then press equal to, this is your answer, the first one. You can see over here, it'll be one of the side. You can see one of the side is 20.8 GH. Yes, x is GH, isn't it? That's 20.8 because nearest 10th we are rounding it off to. And the other one, you can just do the same thing with tan. Tan 32 equals 11 divided by y. That is again over here, you should take it as alpha x and shift and solve. And the answer is 17.6. And yes, we have 17.6. Those are the two answers. But if you want to do the steps, here we got y is 17.6 and over here we got x is equal to, I think so, I just forgot anyways. Let's take x to the other side. That is equal to now 11 and take the sine over here, sine 32. This is it. And over here, y to the other side and it will be 11 divided by tan 32. Even if you type these in the calculator, you get the answer. I'll show you over here. But don't put x because there's no point because everything is at one side of inequality, right? 11 divided by sine 32, that is at 20.75. I mean 20.8 would be the answer. So 20.8. That is GH over here. And this one was HF. So you have found all the sides. Already one side was known and all the angles. So we have solved the entire right triangle. And over here as well, you can just change this to tan. And here we go. That's the answer. So this is how we solve all the sides. Okay, you don't need to. Now over here they have found one side and used Pythagoras theorem. Why would you do that? Because you're using trigonometry anyways. Just use trigonometry, it'll be much easier. What I've done over here would be much easier, and this is absolutely correct. You will get full marks for this as well. So try to go with this method, which is much easier. Let's do the other problems. I'll quickly solve all of these problems. Here it's 90, 57, and then it'll be 33 degrees. And what about the other sides? Now, I will choose 57. What I choose is whatever is given, I choose that as theta. Opposite side, hypotenuse, and adjacent. Now, I have hypotenuse. That means I have to use sine theta equals opposite by hypotenuse and cosine theta, that is adjacent by hypotenuse. These are the two sides. These are the two formulas which I have to use. And then over here, what I need to do is substitute. Sine theta is 57 degrees. And then we have opposite to be unknown. I'll just write opposite side itself, okay? Hypotenuse is 18. And over here, cosine 57 degrees. Adjacent is unknown. And over here, we have hypotenuse to be 18. So now 18 to the other side will be 18 times sine 57 degrees. That is equal to opposite side, that is WX. And over here, cosine 57 degrees multiplied by 18. That is equal to adjacent. Adjacent is XZ. So now all you do is put it in the calculator and get the answers. Here it's 18 times sine 57 degrees. Close the bracket. The answer is 15.1. Nearest 10th, it will be 15.1. And over here, all you do is just change this to cosine, and it's 9.8. Even you can put this second, just after substituting in the formula, you can put it in the calculator and you will get it. So this is the answer. It's 15.1, 9.8. That's it. And the other one was 33 degrees. Let me solve this as well. Here, 8 is, okay, there are two sides known and none of the angles known. So now here you have to be a little bit careful. So there's none of the angles known. Let's see which side do you want to solve first. You just choose J and K. I'll just go with J. Okay. So this is, I'll consider to be theta. The opposite to 90 degrees hypotenuse. And then this is the opposite side. And over here, what is this? JL is adjacent. You can either solve this degree first and then solve the other side, or there are other ways. You can consider this to be theta and then change the theta. I won't suggest you to change the theta, because if you make this theta, then this is the opposite and adjacent. Students sometimes don't change that. So now I will just go to this one single method. I'm not going to teach other methods. I find this is to be easiest among all. See what are knowns. Opposite side is unknown. We don't know theta, but we can solve from hypotenuse and adjacent. So if you have cosine theta, you know what? This is sorry, adjacent and divided by hypotenuse. And over here, we don't know cos theta. That's fine, but we know adjacent side is 8 divided by 22. We had solved similar problems, isn't it? So theta will be cos inverse of 8 by 22. You just put this in the calculator and find the theta. Here it's cos inverse of 8 divided by 22. And the answer would be 68 point, nearest tenth would be 68.7. Theta is 68.7 degrees. 68.7. Now we know this is 68.7. Now, instead of finding the other thing, I'll find the opposite side. Now I'll change the formula from cosine theta to sine theta. Why? Because over here now I can find opposite by hypotenuse, right? Sine theta, or you can use tan theta as well. It's up to you. I'll just use sine theta, and now here sine theta is 68.7 degrees. And what is the opposite side? Opposite side is unknown. That is what we need to find, L and K, and divided by hypotenuse is 22. So now 22 to the other side will be 22 times sine 68.7 degrees. That is equal to LK or KL. Just use your calculator over here. 22 times sine 68.7, close the bracket. That is equal to 20.499, makes this to 5. The answer is LK is equal to 20.5 units. Now we have not done all. We already have this adjacent and hypotenuse, so we found the opposite, that is 20.5. Now one angle is remaining. How do you find the angle? We know all the angles of a triangle are 180 degrees. So 180 minus 90, that is the right angle, minus 68.7. That will give you the other angle, that is 21.3. So this is 21.3 degrees. So this is how we solve each part of the right angle triangle. So you can see LK is 20.5. Now this one over here is 69. Really, we have to round it off to the nearest tenth. Oh, I'm so sorry, I didn't read the question. Look here. Guys, round the side measures to the nearest tenth. That means all the sides we do it to nearest tenth. And the angle measures to the nearest degree. This means we have to take the entire degree. Theta is how much? 69. Make it to the next degree. Now here, theta is 21 degrees. Because it's 3, it's less than 5. So we keep it as 21 degrees. Very important thing which I just didn't realize it until now. In the question it was mentioned. So please make sure you do that accurately. And here as well, it's a similar problem. Oh no, here it's very easy because the angle is given 32 degrees. This is 90, so this one will be 58 degrees. 7. Now I'll consider this to be theta, opposite, hypotenuse, and this is adjacent. So we know the hypotenuse. Sorry, we know the hypotenuse, that's 7. So I will use hypotenuse formulas, that is cosine theta is equal to adjacent by hypotenuse, and sine theta is equal to opposite by hypotenuse. Now here cosine theta is 32 degrees, and adjacent is unknown, but that is what we are solving. ST, I'll write it as hypotenuse is 7. Now here sine theta is 32 degrees, but the opposite side over here is unknown, that is RT, but we know hypotenuse is 7. So you just take 7 to the other side, 7 times cosine 32 degrees. You don't need to write 32 degrees here when you're substituting to solve it. That is equal to S. And 7 times sine 32 over here would give you RT. So now just use the calculator to solve these. 7 times cosine 32, that is equal to 5.93, but side measures are to be rounded off to the nearest tenth, that is 5.9 itself. Over here it is ST equals 5.9, whereas what about RT? Just change this sine to cosine to sine, and you will get 3.70. That's just 3.7. So the answer is 3.7. Now you can also directly substitute this substitution in the calculator and get the answers directly. So the answers are 3.7, 5.9, and this was 58 degrees. Last two problems, we'll quickly do them. Over here, we have one angle 90 degrees and the remaining angle will be 65 degrees. So then we have this side. Now I'll take this as theta. That's the 25 degrees. So opposite side is unknown, hypotenuse is known, and adjacent side is unknown. So again, it will be sine theta equals opposite by adjacent. Cosine theta is adjacent by, I have written the sine theta formula wrongly, sorry for that. It's opposite by hypotenuse. This is hypotenuse HYP, adjacent, opposite. Now here sine theta is 25 degrees and opposite is unknown. I'll write it as AC divided by hypotenuse is 12. Cosine 25 degrees, that is equal to adjacent is basically given as not unknown, it's CB or BC divided by 12. Now you take the 12 to the other side, 12 times sine 25 degrees is equal to AC, and over here 12 times cosine 25 degrees will be equal to BC. So here it is 12 times sine 25, that is equal to 5.07, that will be 5.1, and just change this to cosine. This will be equal to 10.9 because 87 makes it 9. So it is 10.9 and 5.1. You can see these are the two answers. And over here it was 65 degrees. Yes, as it is. And the last problem, and it's been a long explanation video. So because all the problems are included, you can just skip whenever you've understood thoroughly. But now we will be solving the last one. This is 45, and over here also it will be 45 degrees. You can just use the normal way, but there is one way you can easily find what is this. This is an isosceles triangle. If the two base angles are equal, then it's isosceles triangle. If this is 18, then this has to be 18. So these two are 18, these two are 45 degrees. And now over here, you can use Pythagoras theorem to solve this, or you can use trigonometry. It's up to you. If you can't remember this, you can just use the trigonometry, just like how we have solved the previous problems. But over here, since the bases are 45, 45 and 90 degree, whenever the two bases are equal, imagine this was 30 and 30, or 60 and 60, anything. So then this makes it isosceles triangle. The legs will be equal. These two sides are equal. If this is 5, this has to be 5. So here, this is what, this is how we can directly find this length to be 18. And then I will use Pythagoras over here to just solve it up. I'll consider this to be x. X squared is equal to 18 squared plus 18 squared. X is equal to square root of 18 squared plus 18 squared, and x is equal to 18 root 2. Or you can just put in the calculator, square root of 18 squared plus 18 squared, and the answer is 25.5. That's the answer. It's 20.5, 25.5. The other one, MQ, was 18. And here we have 45 degrees. So that is finally the end of the question to its long video. I hope all the problems are clear. If you have any other doubts, please post them in the comments and I'll try to get back to you very soon.